Welcome back to Precalculus. This is the more on, that's two words, 2.6 part B. I guess B is kind of redundant since I said more on, but, and again, you're in Precalculus. Let's do a few more examples. So I'm going to now take a look at, first, before we get to our example, we're going to do that list that I promised you in the last video. By the way, if you didn't see the video, the about 10.5-minute video with the two examples, go back and watch that one. This will make more sense. So now that we've seen a few examples and tried a little bit of trial and error, let's see if we can generalize some things. So this is a list for graphing rational functions. So I'll just say graphing tips. The book has a similar list on page 187, I believe. First thing I'm going to say is factor, if possible. Maybe I should have said if possible factor, but same thing. Factor if possible, and cancel if possible. So if you can do any of that kind of stuff, do it. And like the last video showed, if a term cancels, that means you got yourself a hole. Don't forget about that. Okay, but most of the time that doesn't happen. The second thing would be to find all intercepts. Find all intercepts and plot those things. So find all your intercepts and go ahead and plot them. And this is from the upper analysis, well, at least finding the x-intercepts. Right? The y-intercepts, you just plug in 0 for x. There's not much nicer than that. So once you get those, go ahead and plot them on the graph. Then we're going to find all asymptotes. I think that's how you spell it. First, usually we find the vertical asymptotes, and that's found with our lower analysis. Then you find the horizontal asymptotes. That's found with the comparison thing that I talked about before, the degree comparison. If you could write that out, I don't have room. Fourth, and really that's the hard part, then you could plot those. So once you got all the intercepts and the asymptotes, plot them. That's going to kind of frame your graph. Fourth, you probably need to plot additional points. So I'm going to say plot additional points. And I like to plot them near the vertical asymptote. Usually I just do it on one side, the side where maybe you have your intercepts already, just to get kind of a feel for what one of the branches is going to look like. And once you have that, you can sketch the other side, as I'm going to say here. Sketch the curve smooth and symmetric. So just sketch the other branch symmetrically to the first side. So that will get us going. And if you look back over the first two examples, look over the few examples in the book, that's the kind of stuff we're going to be doing. I'm going to do a harder example next. This is one that is going to have a slant asymptote. This is not probably that big of a deal. I mean, it's important to know, but primarily focus on the basic ones, I would say. But an example of one with the slant asymptote would be x squared plus 1 over x plus 3. If we just flew in our process and said, let's do our upper analysis, the numerator set equals 0. Wait, that's impossible. Right? X squared plus 1 can't be 0. Because x squared has to be greater than or equal to 0. You add 1 to it, you're greater than or equal to 1. Lower analysis. Can't get much nicer than this. X equals -3. That is our vertical asymptote. Now if we did the comparison step, we would probably say this. Horizontal asymptote, none. That is true. There's no horizontal asymptote, but there's an asymptote. there's another asymptote. Especially, we're only going to do ones where the degree is the numerator is 1 degree greater than the denominator. And in that case, there is a linear asymptote. We call it a slant asymptote. So the way we find it is we're going to have to do some division. We could simplify f of x, and really, from now on, when you notice the degree is 1 in the numerator is 1 greater than the degree in the denominator, divide. I'm going to do synthetic division. So don't forget your placeholder. I'm actually expecting a non-zero remainder. If there was a zero remainder, that would mean x plus 3 is a factor. If it was a factor, the numerator should be factorable, and I should have noticed they canceled, giving us a whole. But the numerator is not factorable. So let's hope we don't get a remainder of 0. Yes, we didn't. We got a remainder of 10. That means f of x, yes, it's x squared plus 1 over all x plus 3, but it's also x minus 3 plus 10 over x plus 3. This is an interesting result. Actually, our upper analysis, none of that stuff's wrong. There's still no x-intercept. There's still a vertical asymptote at x equals -3. But in this form, we can see something kind of unusual happen, that you can find your horizontal asymptote if you think a little bit. Let's see. If we were to imagine x becoming massively large, this term's going to do what? It's going to go to 0. So interestingly, as x gets massively large, f of x is going to approach, it's going to look like it's x minus 3. It's going to look like it's a linear equation. So the farther you get from the vertical asymptote, or even 0, the more extreme numbers you get, this is going to look a lot like a linear equation. So yes, it's unbounded. It goes to infinity, but it goes very predictably. It goes in a linear fashion following the x minus 3 curve. Pretty interesting. Anything else I need to write on here? I don't think so. Let's go to a new slide before we graph this, but I think we have all the particulars. Oh, let's write down slant asymptote is y equals x minus 3. Okay, new slide. Alright, so let's actually get this on the paper, on the pad, whatever this thing is. I gotta see if I can actually fit this on the screen. Okay, this is actually my second attempt. My first attempt failed miserably, so I'm actually redoing this. But due to the power of technology, you never knew. Never did you know. Okay, so this is like -1, -2, -3. This is -1, -2, -3. Now our slant asymptote, again, was y equals x minus 3. That is a line with a slope of 1 and a y-intercept of -3. So it's going to go right through there. And it's also going to go through here at 3. If you want to plot a couple of points, that's 1, that's 2. Okay, this is coming together. Did we have any points? There were no x-intercepts, right? Are there any y-intercepts? Well, we'll find that in a moment. So let's actually plot a bunch of points. Let's make a big table over here. What are we calling this? F of x, I believe. Remember I said plot them near the vertical asymptote. So I'm going to start with -2. Do -1, do 0, of course, that's my y-intercept. And I guess I didn't quite follow the order that I outlined a few moments ago. I'm doing the y-intercept later, which is fine. 1, and let's go up to 3, because I see that 3 is kind of where that slant asymptote touches the x-axis. That'll be a good sampling, and we might feel like we need to do more. I'm plugging this back into the original f of x. I guess it doesn't matter if you do the divided form, but the original will be easier. This again is my slant asymptote, not to confuse you. So we're actually done with that. I'm just going to plug these down from what I calculated earlier. You can check me. 5, 1, and trust me, this is much more entertaining than when I did this in the last video. In my first take, I was stumbling over myself and making mistakes. I'm sure you don't want to hear that. Okay, hopefully those are right. Let's plot those points. -2, 5. I'm just going to say this is 5 if you don't mind. So this is really not drawn very well. What else? -1, 1, 0, 1/3. I mean, we're just guessing. 1/3. Come on, how are we going to figure that out? And 1, 1/2, a little bit higher than that other point. And 3, 5. Oh wait, 2, 1. And 3, 5/3. 5/3 is about 1 and 2/3. So we're just getting a sketch here. It's going to look like this, something like this. And then it hugs these asymptotes. So as it gets bigger and bigger and bigger in the x direction, this line is going to just be right on top of that dotted line almost. So really interesting phenomenon how it becomes basically linear as x approaches infinity. Now the last step is to sketch smooth and symmetrically. So what I do is kind of, I'm going to use a yellow because it's hard to see I guess, but kind of measure that distance from that to the closest point and kind of come out the same amount of space. And of course don't draw this yellow line. But and then I'm going to just swing it in there like that. And that's a decent graph right there. This continues out. And there we go. So I think I covered it all. I labeled the asymptotes. The intercept was just the y-intercept there at 1/3 at the slant asymptote. And hopefully that is helpful. I'm glad you made it to the end. Good job. If you want some more help, I would direct you in the book. Some really good examples. Example 1 I didn't think was super useful, but examples 2 through 8 are good. Check those out. So with this video and those examples, hopefully you can proceed through this section 2.6 pretty well. See you next time.